completing the square. So first of all, what is it? Most people, lots of years I taught this, I didn't do a picture like this picture thing here. So nobody really caught on to kind of what we're talking about. And I did this a little bit before, but if you were to say like this side here is length x, and I don't think I'd necessarily try to mark this in, but if each of these is 1, you agree that whole side length is going to be x plus 3, x plus 1 plus 1 plus 1 for that height. And if this side here was going to be an x, and this is a 1, a 1, and a 1, that side's x plus 3. Well, if we wanted the area of the whole thing, we could multiply this x plus 3 times this x plus 3, or x plus 3 quantity squared. And when we do that, we get an x squared, which is this part right here is x squared. We get 6 of these x's. Do you agree this part here is going to be 1 wide and x high? Here's another one that's 1 high, x wide. So each of these is going to be one of those 6 x's. And then we have this plus 9, which is just these 1 by 1 cubes there. Good? Officially, what we're doing in completing the square is going to be we will have something that's kind of missing this chunk here. And we have to figure out what's this that we have to add in, what's this plus 9. Good? And the way we do that is that we use this 6x to figure it out. And I'm going to try to erase all of this and see if I can try to make a little bit more sense of it. But if I would take this 6x, prefer really just the 6, if I divide 6 by 2, do you agree that's going to give me this number right there? Because that number is what gives me my 3x and my 3x. I have two identical things, so cut it in half, I get one of them, which is the 3. So that gives me the 3. And then this 9 comes from doing the 3 times the 3, the last times the last in FOIL, which is that 3 squared. Agreed? So if I were to have a problem, so we'll come back to that exciting math tidbit. All right, here's this next part. All right, so that's coming really soon. If we go to this part here, you guys remember these here, binomial square theorems? Yeah. That we have these two identical things. The only thing different is going to be this one here is a plus, and that matches this plus. This one here is a minus, that matches this minus. Agreed? Okay. And we could come up with this y value one of two ways. We could go through and square root the y squared. Do you agree that would work to find y? Yeah. The other option is this part here is going to be 2 times y times x. So we could take this middle part and divide it by 2, and that would give me the y. So in other words, if I have this problem right here and I want to take and factor it, I'm going to have an x in the front because of my x squared. Agreed? My sign is going to be a plus or a minus. Plus because of this plus right there. And my number has to be a 3. And I could get that 3 by either doing square root of 9 or this 6x, really just the 6 divided by 2 gives me 3. Are you a believer?
Yeah.
The next one is an x because of the x. Plus or minus? Plus because of this plus right here. And the number has to be a 2. Because I could either square root this 4 or divide this 4 by 2. Next one, x minus because of that, 5. And it's either 10 divided by 2 or square root by 25.
This isn't that hard.
Not so far. See, I told you you'd like this section. It's amazing. Ah, I shouldn't have said so far. Okay. X minus 12. Because half of that or square root that thing. Now we're up to this one here. It's going to be an x plus because of this plus. Now we know it needs to be a 4 because of that. But do you agree if I would take this x plus 4, and you don't need to write this, but x plus 4 quantity squared, that's x plus 4 times x plus 4. When I multiply these, it doesn't give me a binomial like this. It gives me a trinomial. So before I can take this and change it into this, I need to figure out what's missing. What has to go here on the end to make it work? And you could either take this thing in FOIL and say, okay, I have x times x is x squared. Then I have my outside plus 4x. I have my inside plus 4x. And my last, my plus 16. X squared plus 8x plus 16. So I know it has to be a plus 16, right? that if I had this plus 16, then you could look at it as though, oh, you square root this here too to get this number. You kind of tracking with me?
Yeah.
But let's do the much faster way. Instead of doing all that work, do you agree I could take this 8 and divide it by 2 and get my 4? What do I do to my 4 to get my 16? I square it or multiply it by itself. And that is where page 2 comes from. So flip the page. Everybody's done with page 1? Okay. So this is what I was kind of getting at the beginning, that this x squared plus 8x is really trying to say, all right, this here is x squared. This is going to be 1x. This is 1x. This is 1x. And so on. 1x, 1x, 1x. Unfortunately, I just have 6 x's there instead of this. But essentially, this part here that we're trying to add in is completing the square. We're trying to add in those numbers there on the end to make it a square. So we can go back and say this has to be an x plus 3 or an x plus 4, or whatever the case might be. Fair enough? Okay. So, but if you're going to add something to one side of an equal sign, you have to add it to the other. That's what I'm trying to get at by this here. What would you have to add to both sides of an equation to make it a perfect square? All right. So x squared plus 10x plus 25. The 5 is halfway there, because if we cut the 10 in half,
Oh, yeah, because we got to square the 5.
yep, cut the 10 in half, we now know that it's going to be an x plus 5. But we have to square that 5 to get the 25. On the next one, right here at the end, we put a plus 9. Because 6 divided by 2 is 3. 3 squared, 9. All right, next one. Still a plus. It's always a plus.
5. No, I got this. I got it.
15 squared,
Dang it.
225.
Oh, I was just going to say.
Whoa! That's a
We're
big
focused. We're focused. Next one is going to be plus. Nice, plus 1. That messes up some people. Because typically that number at the end, the c value is larger, but it doesn't have to be. 2 divided by 2 is 1. 1 squared is 1. This last one, 7 divided by 2 is 3.5. When we square it, we get a 12.25. So plus 12.25. And it's always plus. So if you wanted to, you could say, okay, that right there, it's going to be b divided by 2. Should we take whatever's in front of x and divide it by 2? And then we have to square it. So b divided by 2, quantity squared. Are you tracking with me? Does it make sense?
Yeah.
Okay, so we're good up to that point?
Yep.
Now, here's kind of why. Doing that to a problem can get us to a place where we can quickly find the x-intercepts, or the zeros we've been calling them, of a function. So the next sheet gives the instructions for how to factor by completing the square. Before we jump to it, though, note, if you have the square root of a negative number, there is no solution. Correct. So there is no solution. So in other words, what we're trying to find in these is we're trying to find what are these x values where the height is 0. If you have, where you're working through the problem and you get like a square root of negative 10 or square root of any negative, that's telling us you either have this situation where the parabola is all above the x-axis, so there's no real x-intercept, or you have this situation where your parabola, your quadratic, is all below the x-axis. Ready for page 3?
Yep. Ready?
All right, page 3. So this here, don't let the number of steps intimidate you. You'll get to the point where you just kind of rattle through things pretty quickly. So this is the way I'd recommend doing it. I tried going through and coming up with what are the fewest number of steps that work in every single problem. Do them in this order. And sometimes you can skip a couple of the steps, but I'd encourage you to try to learn it this way. You get some people that try to do it with like crazy decimals, and I really think this is going to be the easiest. I'd encourage you not to try to be super creative. All right, so first thing, rewrite so one side is only x terms. In other words, you just want to have like the some number of x squareds, and then plus or minus some number of x's, no numbers by themselves. So solve this thing here by completing the square. So I'm going to get rid of minus 21 by adding 21 to both sides. Gives me what's here in black. You okay with that? So that's this step 1. Step 2, if a is the number in front of x squared, right? So this number in front of x squared is 3 here. If that's not equal to 1, divide all of both sides. I should have an of in there. Divide all of both sides by a. So I have this 3x squared minus 18x. I'm going to divide all of the left by 3 and divide the right by 3. Still good? The two most common mistakes, one of them comes up, people divide this and get an x squared, and they leave this as minus 18x. They forget to divide that by 3. So kind of keep an eye out for that. That's almost, I'd say probably 40% of the mistakes happen right there, that they just leave this as a minus 18. Still good? Now, once we're to that step, we do what we were just doing in that last sheet. That last sheet, we were figuring out, okay, what do I have to add here? So that's the add. You cut b in half. I wrote it as b over 2 on the last page, but cut b in half and then square it and add that to both sides. This is figuring out that bottom right corner of that square thing we did the picture of. So half of 6 is 3. 3 squared is 9. Because it's in equals, it's an equation, I have to add 9 to both sides to make it so it's still equal. Still good? Doing that gives me this line here in black. Now I can go through, because I know this is a perfect square trinomial, I can factor it into a binomial squared. So that's what we were doing on, I believe, the first page. So I can take and say, all right, x squared, that's going to give me my x, and then to get the, well, minus because of that minus, because this is always plus. And then I either square root my 9 to get 3, or I cut 6 in half to get 3. You guys good for this black thing here? X minus 3 in parentheses squared equals 16. Now we do what we were doing in the last section. We have something that's squared. If we want to get rid of that square, we square root both sides. Agreed? So step 5. Now this is just where we go into what we did in the last section. Square root both sides. And then that's going to give me absolute value of what's in parentheses. Absolute value of x minus 3 equals the square root of 16 is 4. And then we finish it off just like we did in the other class. So break this up into two different parts. So I have x minus 3 could be a positive 4. So x minus 3 is positive 4. This could be a negative 4 because absolute value of negative 4 gives me 4. So x minus 3 could be negative 4. Solve them both for x, so add 3 to both sides, add 3 to both sides, and we get our two answers. So we get x equals 7 or x equals negative 1. These are my two x-intercepts for that parabola. And I had to slip in there a step 7, check your answer. That's smart. Most of us probably don't do that, but in theory, if you're one of the smarter people, you could put a 7 in for these two x's, punch it in, see if you get a 0. Then put a negative 1 in for both x's, punch it in, see if you get a 0. You could check your answer. So, for the truly diligent. So, yes?
Yeah.
Cool. You might want to keep this page kind of close by when you start trying to do them on your own. Thinking, well, so let's do this first one together and then probably turn you loose on the second one unless people are looking horribly, totally lost. So just kind of have to flip back and forth. So first step is we want one side with just x's. So we need to get rid of this plus 24. We get rid of plus 24 by?
Minus 8.
Perfect. So I'm going to subtract 24 from both sides. And that leaves me with a 2x squared minus 16x equals a negative 24. Okay. Now, second step is look in front of the x squared. If there's something there other than 1, then divide all of both sides by that number. You'll notice this here is a 1x squared, so you get to skip this step in the second question because it's already just going to be an x squared. But here we have to divide both sides by 2. And that gives me an x squared. Nice, minus the 8x. That's one big mistake there. I'm going to leave a little space because we're going to have to add something in there later. You'll probably forget that a whole bunch of times. Don't worry about it. But then that equals a negative 12. Now our third step was we're kind of working towards being able to write this as something squared. So this is kind of how I remember the steps. I'm aiming for this. But I can't write this as a binomial squared until I make this a perfect square trinomial. So we got to put a number there, and that number is 16. Because I cut the 8 in half to get 4. And then when I square the 4, I get 16. So I'm going to kind of clump a couple steps together here. On my right side, negative 12 plus 16 gives me a positive 4. Yep, so that just becomes a 4. On my left side, I now can factor that, and I get an x plus or minus. Minus, good, because of this sign here. Just copy that down every time. And my number has to be a 4. So I could square root the 16, or I could take the 8 and divide it in 2, cut it in half.
I have a question.
Sure. All right, so now the whole point in doing this was so we'd be able to go through and square root that thing, and get rid of that squared. And I get a 2 over here. On the right side, I have an x minus 4, but I have to remember to do the absolute value of it. Now we're getting close. So inside this absolute value, in right there, I could have the number 2, or I could have the number negative 2. So x minus 4 could be 2, or x minus 4 could be a negative 2. I take and break that up. Then last but not least, I add 4 to both of those. And I add 4 to both of these. So one x-intercept is at 6. My second x-intercept is at 2. So my parabola or my quadratic crosses the x-axis at 2 and 6. Yeah. We can do this one together. If you want to work ahead, go for it. Actually, I kind of skipped a couple steps here. I put this one in because the book did ones like this and messed people up, so maybe we should do it together. So the first step, the whole point over here of this subtracting 24 was to get it so I just had x terms together on one side. So you'll notice they already did that first step for you. X squared plus 14x is all alone. The 15 is kind of on the opposite side. Fair enough? So we can skip this first step that got me from here to here. And then the whole point of dividing by 2 was to make it an x squared. Because do you agree it's a whole lot easier to factor this into this than when you had like a 2x squared? Especially if you're trying to figure out what number do you put in there to make it a perfect square. And it's like, yeah. So that's already done for you too. So essentially we're starting going from this, we're starting at this line here. We need to add in the plus 16. So we don't divide because it's already 1x squared. We don't move a number to the other side because it's already there. So we start by saying x squared plus 14x. What do I have to add to both sides? Not close. 7's related. 49. Yep. We divide this thing by 2, and then we square it. So I add 49 to both sides. Plus 49. And it gives me x squared plus 14x plus 49. I didn't write this out last time, but maybe it'll make it better. Equals 64. Okay, so we're up to there. Now, the whole point in doing that was that we could take that left side and make it a nice binomial squared. X plus 7. Perfect. X plus 7. The x coming from the x squared. The 7 coming from square root of 49, or half of my 14. Once we're there, the advantage of having it that way is that we can square root both sides. The absolute value of x plus 7 equals 8. So inside my absolute value, that could either be a positive 8 or a negative 8. So my x plus 7 could be 8, or x plus 7 could be a negative 8. So good? Then last step, subtract 7 from both sides, on both of those. So one x-intercept is going to be at 1, x equals 1, or x equals negative 15. So the two x-intercepts for our parabola or for our quadratic, negative 15 and 1. You good?